All right, I want to start now we have 2 sections left for this semester, so I want to start section 5.6. This will probably have 2 videos if I just had to guess, but definitely at least 2, maybe 3, but section 5.6, and what we're going to talk about in this particular section is we're going to talk about something a little new, still going to involve radicals. You don't have to copy what's up here, don't worry about that yet. I will give you something to copy in just a few minutes. But we're going to talk about radical equations. Now, since we've been talking about radicals, and since we hit chapter 7, all of chapter 7 videos, we've been dealing with reducing radicals. We talked about imaginary numbers when you have a negative under a square root. We've talked about how to reduce radicals. We've talked about how to add and subtract radical terms. We've talked about how to multiply with radical terms. And we've talked about how to rationalize the denominator. This is the first problem that we've looked at where it's an actual equation. Now, the word equation, remember, comes from the word equal, or the root word is equal. So anytime you hear me use the word equation, that means the problem has an equal sign in the original problem somewhere. Now, we have looked at 3 kinds of equations in this whole course together. The first kind of equation that we looked at came from section 2.1. All those equations on test 1. All of those were called linear equations. A linear equation in one variable was where you had one variable, but it was always to the first power. Now, it may be listed multiple times, but when we solved a linear equation, we got the x's on one side and we got the numbers on the other. An example of a linear equation is this one right here. Another type that we covered on test 1 was called an absolute value equation. That was this one. And then the third type that we've covered is this one right here. And we covered this one in section 5.7, I believe. Let's see. Give me just a second because I do. 5.8. Section 5.8. We covered this type of equation, was called a polynomial equation, but we gave a better name for it. It was a second degree polynomial equation, and we called that one a quadratic equation right there. So linear equation, absolute value equation, and quadratic equation. Now, were those equations, were they all solved the same way? Heavens no. But the goal was to solve all of those. In other words, find the answer for x that makes it work. Okay, in this section, I'm going to teach you how to solve a radical equation. Now, first of all, what does a radical equation look like? It's an equation, so it's going to have an equal sign with a radical in it. And so the goal will be to find the answer for x that makes this thing true. So in just a minute, we're going to work this problem right here. So right here, what you're looking at right there is a radical equation. The goal to it is to solve it. Find a number for x that makes it true. Now, I already put up the answer right here, 5. The answer to this equation is 5. Now, let me just show you that it's 5. If you let x be 5, what's 2 times 5? 10. 19 minus 10 is 9. What's the square root of 9? It's 3. So 3 plus 2. Now, this is an x also. It's 5. So is 3 plus 2 5? Yes. So the answer to this is 5. And by the way, there is no other answer to that problem. But now the question is, how do we go from here to here? So I've shown you what a radical equation looks like, but I haven't talked to you about how do we solve it. So how do we go from here to here? So in other words, how do we solve radical equations? All right, so I'm going to uncover this. Pause the video now and copy this down. Okay, I'm assuming that you've copied it down. Let me read this to make sure you got all the words. I know my handwriting's not the best in the world. Steps in solving radical equations. Step 1, isolate the radical term. Step 2, square each side, that's the two key words, and simplify. Step 3, solve the remaining equation. And then step 4, check the answer in the original equation. So make sure you got those 4 steps. I will explain those 4 steps as we go through. So let's look at some examples together now. So if you will, write these instructions down. Solve the following. And the first probably 4 or 5 work like this one right here. Okay, before I work it, first of all, is this a radical equation? Yes, because it has a radical in it and it has an equal sign in it. All right, so how do we solve it? Step 1, isolate the radical term. Well, here's the radical term. Is it on a side by itself? Yes. Step 2, square each side. Now, you say, why do we square both sides? I'm fixing to show you why. So square both sides and simplify. Now, when you square 6, be careful, that's not 12. 6 squared is 6 times 6, which is 36. Now, look at the left side. You're squaring this square root. Let me come over to the side. What does it mean to square something? You say it times itself. Now, what did we learn in the last section? When you take a square root times itself, what does it do? It just gets rid of that square root. So, why do we square both sides? To get rid of the square root. So when you square that square root, it just leaves what's under there. Now step 3. Look at your equation now. Notice it is no longer a radical equation because there's no radical left. What kind of equation is this then? This is a linear equation. X to the first power. This is what we did in section 2.1. How do you solve a linear equation? X is on one side, numbers on the other. So I got to get rid of this coefficient. You have seen me do that many times in here. To get x equal 18. Now, step 4. Now, step 4 is where I want to spin my wheels just a little bit. First of all, if step 4 were not optional, if step 4 were not mandatory, if it was not mandatory, there wouldn't be 4 steps. So if step 4, if it was an option, I wouldn't put it up there. Here's what I mean by that. On these radical equations, all radical equations must be checked. Here is the reason. When you solve a radical equation, I'm not going to go into all the reasons why. When you square both sides on that step 2, sometimes it produces an answer that's called an extraneous solution. Basically what that means is it's a false answer. Sometimes it works, sometimes it doesn't. So in every one of these radical equations, when you finish step 3, that answer that you're looking at has a 50-50 chance of working. So the answer is either going to be 18 is going to really be the answer, or if it doesn't work, there's no answer at all, in which case I'll say no solution. So it's not like the other equations. When you finish it, you can circle the answer. So what I've got to do is check this. All right, a couple of things I want to tell you about if you did not know anytime you check an answer in mathematics. Number 1, anytime you check an answer in mathematics, you always check it back in the original problem before you touched it. So the first thing I will do is I will plug that in. I will write the original problem back down. The next thing when you're checking an answer is you take the number you're checking and you're going to plug it in for x. But when you do that, that's the number I'm checking. When you do that, you don't, when you plug the number in, you'll hear me say this a bunch in these problems. You'll hear me say, do the math. In other words, when you plug that number in, you don't square both sides anymore. You don't do all of that. You plug that number in and do the math on the left, do the math on the right, and if the equation ends up being true, then that's your answer. So do the math. All right, so let's plug in 18 right here for x. So this would be square root of 2 times 18, which is 6. Square root of 36, which is 6, because 2 times 18 is 36. And is the square root of 36 6? Yes, that's true. So since both sides are equal, that means that the number I'm checking is the real solution. So the answer to this problem is x equal 18, and that is the only answer to this problem. Okay? Let's do some more. Square root of 2x minus 1 equals 7. Step 1. Here's the radical term. It is right by itself. I'm going to work one in just a minute where it's not, but this one is. Step 2. Square both sides. And simplify. So when you square the right side, you get 49. When you square that square root, as we've already talked about, it just gets rid of it. Step 3. Solve the equation that is left. Well, this is a linear equation. X is to the first power. So we're going to get the x by itself. First, you have to add 1 to both sides. And then divide by the coefficient. So you see a radical equation ends up taking you back, in this case, to a linear equation. Now step 4 is that, notice I didn't circle that answer. And the reason is it has a 50-50 chance of working. So what I've got to do is I have to check it. And when I check it, I must show my check work. So let's write the original problem back down. And the question is x equal 25? That's the question. Does it work? All right, so come right here and put 25 in for x. Don't move anything. Don't square both sides. Do the math. All right, so up under the square root, 2 times 25 is 50, minus 1. Do the math. 50 minus 1 is 49. Do the math. Square root of 49 is 7. Is that true? Certainly it's true. 7 is equal to 7. So the answer to this problem is x equal 25. Okay? Let's do another example. All right, be careful right here, because if you skip any step, then I'll throw off your work. So here we go. Step 1, isolate the radical term. Now, I'm going to underline the radical term. There it is. Is the radical term by itself? No, because you got this adding 7 here. Now you can't add that 7 to that 3 because that 3 is under that radical. So step 1, this radical term is not isolated. To get rid of the adding 7, you have to subtract 7 from both sides. So when I do, I get square root of 2x plus 3 equals 2. If you you win 2 and you lose 7, you are down 5. That's step 1. Step 2, square both sides. So you're going to have to memorize the steps to these. When I do, I get 2x plus 3 equals negative 5 squared is negative 5 times another negative 5, which is a positive 25. Step 3, solve this equation. It's a linear equation. Subtract 3 from both sides. That's not a dividing bar. I just underlined it. So subtract 3 from both sides. So I get 2x equals 2, 22. Divide by 2 to get x equal 11. And then step 4, I'll do it up here. I have to check this. Now, when I check it, where do I check it? Back in the original problem. So I'm going to write the original problem back down just like it was. Make sure you got all that, yeah. So write the original problem back down. Now I'm going to let x be 11. So I've got square root of 2 times 11 plus 3 plus 7 equal 2. Let me say again, don't subtract that 7 across. Don't move anything. Do the math. All right, so this would be square root of 2 times 11 is 22 plus 3 plus 7 equal 2. This is square root of 22 plus 3 is 25 plus 7 equal 2. Square root of 25 is 5 plus 7 equal 2. 5 plus 7 is 12 equal to. So question, is 12 equal to 2? Well, no, it's not. This is not true. No. So that means the number that I plugged in for x, because it didn't make both sides be what? Equal, the number that I'm checking doesn't work. So let's see, that number x equal 11 doesn't work. So if it doesn't work, and being that's the only potential answer I found, then what am I to assume? If that was the only answer I found and it didn't work, then the only thing that I'm to assume then is that there is no solution to this problem. That's why it's important that you check your answers. Because had I not checked that answer, I would not have any way of knowing that that solution actually did not work. All right, I'm going to stop here because I'm going to do 2 more examples in the next video, still in section 7.6, is it? Yeah, 7.6, part 2 video on solving radical equations.